Hi everyone, I'm Julia from Krannich Solar. Thanks for joining our webinar today with Canadian Solar. Before we get started, I will be giving a quick presentation about Krannich. Krannich Solar is headquartered in Germany and was founded by Kurt Krannich. Since being founded, Krannich has expanded into 26 different countries and can ship to over 100 countries. As a privately owned and self-financed company, we hold a significant market share and rank among the leading solar wholesalers globally. With 29 years of experience in delivering solar products worldwide, we've become experts in the field. Our international purchasing power helped us build strong relationships with your favorite manufacturers, such as Canadian Solar, to secure the best pricing and availability. In 2005, Krannich expanded into the US, opening our first branch in New Jersey. Today we have branches in California and Florida, and we're expanding into Texas with additional warehouses across the nation. Our US team consists of over 80 employees that service the Americas and strive to offer the best service and options to our partners. We are growing every day, so keep an eye out for where we might be next. Krannich is the top partner for installation companies seeking PV system products. In our role as an internationally operating wholesaler, we can make a significant contribution to shaping the energy transition. With every PV system we supply, we come closer to the target of carbon neutrality and fulfill our mission of paving the way for 100% renewable energies. Our company values are the drivers of our success and our inspiration in a dynamic market. Throughout the years, we have grown our product portfolio to provide over 5,000 products. We have partnered with leading manufacturers worldwide to offer the best material for a project of any size, whether it's an off-grid system, 4-panel shingled roof, or a megawatt flat roof. Choosing Krannich Solar means you'll never work alone. Our streamlined ordering process ensures that each customer receives a dedicated sales rep, guiding them through every step from project design to on-set delivery. The solar industry is always innovating and changing. At Krannich, we're committed to keeping you informed about the latest products and technologies. We collaborate with industry leaders and seasoned professionals to offer first-hand training on everything you need to know, and it's always for free. And this concludes my portion of this webinar. Here is our contact information if you would like to reach out for a quote or if you have any questions regarding the products or services we offer. And if you have any questions throughout the presentation, please feel free to ask them using the question box and we will be answering them at the end of the presentation. Thank you again for joining us, and now I'm going to pass it along to the team from Canadian Solar.
Thank you, Julia. Hello and welcome. My name is Jocelyn Gervoso, and I'm part of Canadian Solar's marketing team. Thank you for joining us to learn about our new high-power residential TOPCon module. I'm happy to introduce you to our presenter and subject matter expert, Danai Argyri. Danai is our product manager of modules for North America. She has over 6 years of experience in the residential solar sector and a background in electrical engineering. She has served in roles ranging from electrical engineer, design engineer, and quality engineer to product manager throughout her career. During her tenure, she has supported the introduction and implementation of various product lines, including energy storage system solutions and various PV module series. Moderating the Q&A session is Philippe Gregoire. Philippe is our Director of Product Management of Modules for North America and has a mechanical engineering background. He started in the solar thermal industry and then transitioned into photovoltaics and product management over 10 years ago. Today's presentation will be about 45 minutes. Here's what we're going to cover today. First, I'll give a brief overview of Canadian Solar and cover some recent highlights. Then Danai will give you an overview of our North American module portfolios. Then introduce our newest TOPCon residential module and dive into the technology advantages that make this module ideal for your installs. Before we start, I would like to share a video with you on Canadian Solar and how we are making a difference in the solar industry. I hope you enjoyed the video. Now let's learn more about Canadian Solar. Canadian Solar is one of the leading module companies in the solar industry, a provider of complete system solutions and a developer of utility-scale solar power and battery storage projects. Our mission is to power the world with solar energy and create a better and cleaner Earth for future generations. Canadian Solar was founded in 2001 in Ontario, Canada, and we have been listed on the NASDAQ since 2006. And we are the top five global module brand. Can you guys see the slides? Okay, great. We have two divisions, manufacturing of modules and energy solutions, which focuses on the development, manufacturing, sales, and customer relationships for modules and inverters. Our second division is our project development of global energy, focusing on the development and construction of utility-scale solar plants and projects. We have a presence in 25 countries and territories, have shipped modules into over 150 countries, and have delivered over 75 gigawatt modules worldwide. Looking at module production, you can see how our production capacity has grown steadily year after year. Canadian Solar was ranked the #1 bankable module supplier by Bloomberg New Energy Finance in the 2020 Bankability Survey with 100% bankability 4 years in a row. Now I will hand it over to Danai, who will take us through our product and technologies.
Thank you, Jocelyn, for the introduction, and thank you everyone for attending this webinar. Let's start with the product overview part of the agenda. On this slide, you see our North America module portfolio for 2024. As you can see, it's segmented into 3 different categories: residential, commercial, industrial, and utility. Starting from the right, we have the module series targeted mostly towards utility markets. If you notice, the module names are very similar. The model with MB in its name is the earlier version using PERC technology and going up to 665 watts. The TB model, currently in production, uses TOPCon technology, which we will dive further into during the webinar, and this way it can boast a power output of 710 watts. Both these modules series are designed with a 210 millimeter wafer, which is the equivalent of a G12. Moving on to the overlap of commercial, industrial, and utility, we have, again, a PERC module and a TOPCon module. The PERC module, which some of you may already be acquainted with, goes up to 550 watts, and like the remaining modules we have in this portfolio, so the 2 commercial, industrial, and the residential we are presenting today, have a rectangular 182 millimeter wafer. The TOPCon commercial and industrial module, the CS6.172 TBH, boasts a power output of up to 615 watts and is going to hit the market in 2024. Consider this module the commercial version of the module we're going to be discussing today, the CS6.1 54 TMH black on black, hitting production in May 2024. With a foreseeable power output of up to 465 watts, this TOPCon module is the successor to the CS6 line, which went up to 445 watts. Before we go any further, let's launch a quick poll to get a better understanding of your needs. Please take the next 30 seconds or so to answer which feature is most important to you in a residential module. Julia just launched the poll, I believe, and we're going to give you some time to answer it. We already have some patterns emerging. I'm not going to jump the gun, but yeah, we have some trends. Okay, poll is closed, results are in. So 55% of you voted for high power and efficiency, 36% for high temperature and improved long-term reliability. And lastly, with 9% of the vote, we have longer warranty period. So the good news is that no matter your answer, we really tried to get you covered with this module. More specifically, we have 8 key advantages that I think cover all bases. We will be going into each advantage in detail, so I'll avoid reading everything one by one in this slide. Let's start with the first two, module power and efficiency, which was the highest rated answer in the poll as well. So here you have it, the CX 6.1 54 TMH in an all black look that makes for an elegant addition to any homeowner's rooftop with its homogeneous look that blends right in. The current output power range for this module is 445 watts to 465 watts. With efficiency being positively correlated to the power output, it reaches an impressive 22.8% for the 465 version. Efficiency also measures how well we utilize the surface area of the module. So what we've done in previous lines and continuing with this one is bring cells closer to one another. As you can see here in the bottom right image, traditionally the cell spacing used as an industry standard is 2 millimeters or more. That is to allow for a proper transition of the ribbon from the top surface of one cell to the bottom of the next one. The reason being is if you bring these cells too close to one another and you encapsulate your laminate, essentially compressing everything, that could create a stress concentration at the location where the ribbon transitions, which would lead to microcracking and a decrease in performance. What we've introduced in the past and maintained with this module is the HTR ribbon, which provides the cross-sectional shape that is needed on top of the module, with that shape then being flattened out near the point of transition to have a better distribution of stress and allow the cells to be closer to one another, allowing the same number of cells to fit into a smaller surface area. Tying this back to the module dimensions, we can fit more cells in the same surface area. If you notice, this module is slightly longer than its predecessor, the CS6. However, with its power density, it can make it so that you need fewer modules to achieve the same system size. The dimensions are in line with other residential modules in the market and also our own previous series, which makes it very agreeable module for residential installations. Staying right above 50 pounds without hitting the 51 pound mark also makes this module quite manageable for residential rooftop installations. Moving on to the next feature that sets this module apart from previous lines, its use of TOPCon technology and the inherent advantages of its 182R cell. Now, this slide is somewhat overwhelming, but stay with me. We're mostly focusing on the TOPCon aspect of it, with the rest being points of reference for comparative purposes. With TOPCon, we have great efficiency and strong bifaciality, even if that specific advantage doesn't come into effect with this residential module. And these advantage points become even more beneficial when we relate them to the silver consumption associated with the production of a TOPCon module, which is not restrictively high. The TOPCon manufacturing process is also easily adjustable from a standard manufacturing setup, which makes the 12 steps associated with it not really an issue. With TOPCon boasting these advantages and with it going for a share of the pie previously solely enjoyed by PERC, we decided it was the best direction to take at this time with this series. On to the next key feature, the module's optimized frame design, which allows for higher pressure limits. Before we go into the pressure allowances themselves, let's consider how we get to that point. Here we introduce 3 modes of mechanical testing that we go for at Canadian Solar. Let's go into each one. Per the standard, Mode 1 is mandated by code and is concerned solely with safety. The standard calls for the maximum load that may occur during the lifetime of the project to be tested times a safety factor of 1.5 as a static load. Essentially, it provisions that this maximum load can occur without causing any physical deformation to the frame, causing glass fracture or breakage, or causing the module to fly off the roof and whatnot. It aims to prevent any safety issues in the field without concerning itself with any production losses or similar performance issues. That being said, there's more that can happen during the lifetime of the project. Despite maybe never encountering that maximum load, you will most likely encounter some snow or wind events that could affect the performance of the module. On a heavier snow day in the winter, you will have a higher load applied to the module that could lead to microcracking. That is not an issue specific to Canadian Solar, it pretty much just comes with the territory, but where Canadian Solar differentiates itself is in all the measures it takes to minimize the effect of a possible microcrack. One of which being the Mode 2 testing, which allows us to better understand how well the module can sustain these pressures and how that affects its performance. In this mode, we apply this force as a static load, and then we do dynamic testing, in essence, cycling the module to see how the crack propagates and how that affects its performance. Lastly, as the module is exposed to wind and other phenomena on a daily basis in varying intensity, that module cycles up and down, and that can weaken the material through fatigue. So even though Mode 1 shows us that we can sustain a maximum load, what we aim to avoid through Mode 3 testing is a scenario where over time, due to varying loads, the material is weakened through fatigue, hence the name fatigue mechanical load testing. What this testing sequence provisions is mechanical load testing that goes beyond 10,000 cycles at different amplitudes to verify that beyond the performance aspect of it, the module is reliable and safe to be installed over a period of time, usually 25 to 30 years, that it will be installed in the field. Following all these, and most often before these tests even take place, we use what is called flash testing and EL imaging. Flash testing measures the power output of the module to see if there was power degradation during the test, and EL imaging, which stands for electroluminescent imaging, is highlighted by this picture in the middle above Mode 2 and provides detailed visuals on module performance indicators that wouldn't be properly spotted through the naked eye, such as microcracks and dark spots. Lastly, as mentioned previously, we do use a safety factor of 1.5 to account for variability in material and manufacturing. Since we're on the subject of reliability testing, I wanted to provide some insight into the culture, mindset, and facilities behind our testing practices. These are all photos from some of our testing labs, which are third-party certified, also known as witness labs. This equipment and methods from the piston actuator test platform used for the mechanical load testing mentioned earlier to the EL imaging and flash testing we talked about in the previous slide, all allow us to take our products through the ringer and stand proudly and confidently behind the reliability warranties we put in place, which not only gives us a competitive edge, but also facilitates great relationships with our customers and allows us to have the name that we have in the solar world. So, onto the promise section of this feature, the frame and pressure allowances it ensures us. On the bottom left, we have an architectural drawing of the frame. Here you notice the back bar, which allows us to boast high downforce allowances in, for example, snowy conditions. The frame cross-section was also optimized in that we played around the cavity, the thickness, the width, the return flange, the manner in which the laminate sits within the jaws. And that's how we're also able to boast the high uplift allowances. On the bottom right, you see the fork clamp mounting configuration that allows us to go up to 7,000 Pascal downforce and 5,400 Pascal uplift. You'll notice that we want to keep this distance within the specified range of 450 to 550 millimeters, with other configurations allowing for higher or lower pressure allowances with respecting product letter approvals to be available by the time we hit the market. Let's see some more mounting options and their respective pressure allowances. Jump too far ahead. So we went over 4-point clamping, which allows 7,000 Pascal downforce and 5,400 Pascal uplift. If we introduce an additional rail in this configuration and go to 6-point clamping, that actually allows us to go up to an impressive 8,100 Pascal downforce and 6,000 Pascal uplift. Especially on the uplift side, that is an extreme advantage. I'm not entirely sure where we would be seeing those pressure requirements, but if your project requires for it, if your peace of mind requires for it, we can provide it with that additional rail. If you want to go for a more minimalistic look, you can go for the 4-point return flange, where essentially you're using this part of the frame cross section to mount the module. And the way you can do that is with a camel clamp by Iron Ridge, mostly. We do have an alternative 4-point clamping method if you want to do the landscape configuration instead of the, not landscape configuration, but run the rails along the long side of the module instead of the short one that we reviewed earlier. With increased distance, we do have to decrease the pressure allowances, and that puts us to 5,400 Pascal downforce and 2,400 Pascal uplift. If you want to be as minimalistic as possible, you can also just go with a railless landscape and railless portrait configurations. These configurations are popular where the pressure allowance requirements are limited, as they use less hardware and through that lower the cost of installation. This method, as its name suggests, does not use rails and instead relies on the strength of the frame as the structural piece transmitting the force to the next mounting point with an interlock between the modules. Likewise, as far as distance concern goes, with the railless landscape configuration, because the distance is shorter between the connecting points, you have allowance of 4,000 Pascal downforce and 3,600 Pascal uplift. Whereas if you were to increase that distance between the connecting points and go for the railless portrait configuration, you would have a 2,000 Pascal downforce and uplift allowance. Now that we've covered the pressure allowances, let's move on to this impressive standard we managed to meet with this module and what that means about temperature considerations, which also popped up in the poll as an important factor for a residential module. The standard we're talking about is the IEC 63126, where we achieved level 1 certification. It's not required in the US, it's more so relevant to other regions of the world where the extreme conditions it covers are more prevalent. The idea is to test at more severe testing conditions to see how the module behaves, and if it passes, the expectation is that the module can withstand much higher temperatures throughout its lifespan. Testing and getting certified for level 1 requires testing at a temperature higher than 70 Celsius, going all the way to 80 Celsius. That correlates to the map on the bottom right. If we're looking at pitched roofs. In the US, you'll notice we cover the entire area except for a little blimp over in the Southwest. Even in that blimp, we're still good to install a safe and reliable module. It just doesn't fall under the scope of level 1, given it exceeds the 80 Celsius provisioned, or it can exceed the 80 Celsius. Again, the standard is not required in the US, so it's just a nice to have, especially seeing how some typically cold areas have been experiencing extreme heat events, but not required in the US. What testing for this standard requires is to increase the temperature for this array of tests. Going into the first test, hotspot test, This one's important because it simulates the module's ability to dissipate heat when part of it is shaded and part of it is exposed to high radiance. What could happen with a subpar module that does not dissipate heat properly? A hot spot is created in the exposed area, which could damage the backsheet of the module and which might subsequently lead to a fire. Additionally, you see we have a UV preconditioning test, thermal testing, thermal cycling, and a bypass diode test. This array of tests is to essentially certify that all the components listed below can consistently withstand these higher temperatures. Next, let's take a look at how this module can be coupled with different module level power electronics, which I'll be referring to as MLPs. The reason we're talking about this is because this module line is most likely going to be installed on rooftop. In the US, there is the rapid shutdown requirement that calls for the ability to limit the voltage of the array within a limited amount of time. That de-energizes the array and makes it safe for workers to work on any electrical equipment upstream of the PV array in the event of a fire or anything else that would trigger a shutdown sequence. This is the role optimizers and microinverters come to assist with. So on the list on the left, represents our compatibility with some of the key players in the market. You see a variety of solar edge products that we are compatible with, as well as with Enphase, where we're compatible almost across the board with our IQ8 line, with the exception of IQX. What you see on the bottom right there is their sizing tool that allows users to see for themselves what product is best for their application, which you can also always consult if you're not sure. Moving back to the list of manufacturers, Tigo is another option, where if you notice the F at the end of some models, that stands for fire and is designated to specifically address rapid shutdown concerns. Hoymiles is another manufacturer that offers microinverters, and they seem to be getting some momentum in the market. So here are some models that you'll be compliant with if you decide to go with that manufacturer. As mentioned in this line below, the final word on compatibility does stay with the MLP manufacturer. So please make sure to always check with them to make sure that the products coupled with our modules are what you need for your specific application. Moving on, we have more power generation through high reliability. Let's see what that means in specific. Reliability is another factor that comes into effect, obviously, when a customer is looking for a module that fits their needs. So here are some examples on how we address that. These are some technological approaches we implement that I would like to highlight. So first off, we have the number of bus bars. The industry standard a few years ago was to have 5 bus bars. What Canadian Solars strive to implement with the larger cells is the multi-bus bar approach. If my memory serves me right, calling for a minimum of 9 bus bars, depending on the cell size used. The idea here is that if a microcrack happens, depending on its location, you may have a part of the module that is inactive. In this example, if we follow the microcrack on the upper left image, we would see that it creates this little triangle that may not be producing. Going over to the right, which has a higher number of bus bars, we see that because of the more narrow strips, we have a smaller surface area affected and potentially not producing. In this photo, we see 11 bus bars, but the case is even stronger in the module we're talking about today that has 16 bus bars. Similar approach with the cell geometry as highlighted in the images right below. When a microcrack occurs, it will keep propagating until it reaches the end of a cell. By splitting the cell in half, we create an edge halfway through the distance that would otherwise need to be covered if we were working with a full cell, therefore reducing the ability of a microcrack to propagate through the cell by half, which is a great accomplishment. And that's why you'll see half cells versus full cells. Similarly, it is useful to know how the module degrades under different types of tests. So let's go through one by one and see where the biggest differences occur. Starting off, we have a temperature cycling test going over for 400 cycles, where TOPCon performs a whole 0.2% better than PERC. Moving on to light-induced degradation, we see that the improvement is at 0.1%, so nothing too exciting compared to the numbers that follow after. As you can see in the damp heat test, where we run it through 1,000 hours of damp heat testing, we have a whole 0.4% improvement in TOPCon as opposed to PERC. And continuing with some higher percentages, we have a 0.3% improvement with the potential induced degradation test. Last but not least, in UV-related degradation, TOPCon tests 0.2% better than PERC. So to summarize all of these findings, we see that TOPCon offers optimized performance in higher temperatures, higher efficiency, stronger defenses against potential induced degradation and light and elevated temperature induced degradation. And overall, that yields us a lower annual power degradation that's going to come in handy when we're talking about our warranty. We touched on hotspots earlier and why they're important. So here I want to introduce a process we have set in place called CSIR, through which we sort and filter cells before they get to module production by looking at them through infrared to identify signs of how the cell would act after being encapsulated into the module. That allows us to sort them out before they way into our production, which allows us better control of this distribution that you see on the left over without CSIR, and narrow it down to a more predictable data set, as you can see in the hotspot temperature with CSIR on the graph. Through that process, we're able to mitigate the risk associated with hotspots much better. That brings us to our last strong advantage for this module: high reliability with 25 years product and workmanship warranty, as well as 30 years performance warranty. As mentioned in the reliability section of our presentation, we really do take our products through the ringer, and that is how we're confident in our warranty numbers. Even when the module is fully designed, it goes through a final third-party long-term reliability test to make sure all necessary criteria are met, not just by our standards, but across the board. The subsequent report can be used to provide developers, financiers, insurance, peace of mind, and confidence in the project they plan to take on with our modules. So now let's dive into the numbers. We're able to offer up to 25 years of product warranty on material and workmanship, which is valid in Canada or US only. And for performance warranty is where honestly we see some of the numbers that are most impressive to me personally. With the 30 years linear performance warranty, and in the specific is where TOPCon really is able to offer an advantage. In previous modules, you may remember a 2% first year degradation and 0.55% annual degradation afterwards. With TOPCon, we're able to get a 1% first year degradation with 0.4 annual degradation. So improvement by 1% in the first year and 0.15% in the years after, which may not seem like a lot, but over 29 years, it actually allows us to be able to boast an 87.4% power output at end of year 30 as compared to year 1. So that's honestly quite an achievement, of which we'll see the implications on the field, and we're very excited to do so. With that, we came to the end of the presentation. So let's summarize our findings. With a 6.1 54 TMH module, you get a great aesthetic for superior project look. You can install pretty much anywhere regarding high pressure allowance, especially with all the mounting methods that we went through. There's a fit for everyone. It has higher power density, which means that the power it boasts is very beneficial when compared to its size and weight. Through all the methods that we mentioned, we are confident in the increased reliability of the product. And we're also market friendly in that we are compatible with a variety of MLPE options. All that neatly backed by a 25-year product warranty and 30-year performance warranty. So before we go into our Q&A session, I would like to launch another poll, Julia, if you might, where I'd like to understand what features you'd like to see in a following residential module. And there's no shame in saying that this is the module you need, because we really try to make it so. But yeah, your feedback is very important to us in developing new products, and your participation is very much appreciated. So let's give everyone some time to go through the poll. Amazing. So actually over half of you, at 56%, voted that this is the module you need. And we're very happy to be able to present it to you and provide you with services. Coming right after, at second place with 22%, we have a longer warranty period. And tying for third place at 11%, we have high power and efficiency, and high temperature and improved long-term reliability, which we always strive to provide. Thank you everyone for participating. And with that, let's launch the Q&A section.
Thank you, Danai, for that excellent presentation. Now let's answer your questions. Please submit your questions in the Q&A section. Philippe Gregoire, our Director of Product Management of Modules for North America, will moderate the Q&A and answer your questions. Philippe, take it away.
Thank you, Jocelyn. So while people enter their questions, I'll start with questions we had previously received. First one being, are these modules Miami-Dade listed? That's a question we get frequently. There is no such thing as Miami-Dade listed. There's an NOA, a Notice of Acceptance, that exists in that county, but that's typically reserved for attachments to the roofs. So the racking manufacturers may apply for them. It's not needed, it's an accelerator, but none of the module manufacturers apply for that. So the way of installing in Miami-Dade is working with either the racking manufacturer or the engineer of record to figure out what the pressure on the module would be, and making sure that falls within the parameters of the manual, similar to what Danai had presented. Another question we had for Danai, what is a test load and how does it relate to my project?
Yes, thank you for the question. The test load, I assume that goes back to the reliability section of the presentation. The test load really just assures us that throughout the time that the module is going to be installed on the field, we get the maximum test load, which is going to be an amount of weight and pressure that most likely will not be experienced, but could be experienced. And we want to make sure that in this case, we are prepared to do that. And that's where our extensive testing practices come into play.
Thank you, Danai. We have one question relating to pricing and how that would compare to the CS6XX. For all pricing matter, I'll refer you back to your Krannich sales representative. They'll be in a better position to help you out, and I'll quote you the module that you're looking for. One other question we received was, to what wind speed are those modules certified? So that kind of ties in often to areas with coastal areas like Miami-Dade and other places on the East Coast or the Caribbean coast. The wind speed alone is not sufficient to establish what's the module pressure that the module needs to sustain. Per the code and per the standard, there's a variety of different factors that need to be baked into the calculation, namely the tilt of the module. As you can imagine, if you're 90 degrees to the wind versus exactly parallel to the wind, that's going to exert a different pressure on the module. The risk category, the way the module is being attached to the racking, all of these things need to be looked at to calculate what's a resulting design pressure. And then, like Danai explained, that will be translated to test pressure on our end. Next question we have for Danai: what kind of testing do those modules go through? How reliable are they?
Yeah, so great question. We obviously do a very extensive mechanical test, but I think where we really get the reliability point across is with the flash testing and the EL test imaging that I mentioned earlier, right? Because that not only allows us to see what the physical, let's say, effect of any pressures that may occur, or any, I guess, complications, how they may affect physically the frame of the modules. I think where we really hammer in the reliability aspect is with the flash test and the EL, because flash test really allows us to see how the power output of the module is affected through that series of tests that we put the module through. And yeah, then the electroluminescent imaging really allows us to go beyond what the naked eye could see and spot how the module behaves on a microscopic level, almost, where we're able to capture information about the behavior of the module through microcrack propagation or what have you on a much more detailed level. So overall, yeah, our reliability sequences and just overall mindset about how we go into reliability, I would say, is one of the factors that really sets us apart and gives us a competitive edge.
Thank you, Danai. Maybe just a compliment, also the fact that we're a manufacturer that has been around for over 20 years, and also having an O&M division, a development arm division as well. We're able to learn from those past designs and those modules out in the field and incorporate that into the development of our new modules. So when we develop a new module, it goes through multiple gate checks with extended reliability test sequences prior to even being sent to a third-party lab facility to validate everything. So you can rest assured that all these modules have been properly tested and vetted before being launched to market. With that being said, that is the last question that we had. So unless there's anything else, I will pass it back to Jocelyn for final words.
Thank you, Philippe, and thank you, Danai, for sharing your expertise. We hope this has been an enlightening use of your time and helps to maximize the value of your solar projects. Canadian Solar has been in the solar business for over 2 decades, and our team has deep expertise. To start the conversation about your solar project, please contact our Canadian Solar representative, Terrence Reed. You can also reach out to any of the Krannich branches listed below. Thank you again for attending our webinar, and have a great day.